In this video, we are going to learn about the definitions of acids and bases. So far in this course, we have used the Arrhenius definition of acids and bases. According to the Arrhenius theory, acids are substances that dissociate in water to produce H+ ions, and bases are substances that dissociate in water to produce OH- hydroxide ions. For example, hydrochloric acid, HCl, is an Arrhenius acid because it dissociates in water to form H+ aqueous ions and Cl- aqueous ions. Sodium hydroxide, NaOH, is an Arrhenius base because it dissociates in water to form sodium plus ions and hydroxide OH- ions. Although the Arrhenius definition is useful, it does not explain all acid-base behavior. For example, ammonia, NH3, forms a basic solution in water even though it does not contain a hydroxide ion. The Arrhenius definition also does not describe acid-base reactions that occur outside of aqueous solution. Additionally, free H+ ions do not actually exist by themselves in water. Instead, they bond to water molecules to form what's called a hydronium ion, H3O+. To explain these situations, we need a broader definition of acids and bases. The Bronsted-Lowry theory provides this expanded definition. According to the Bronsted-Lowry theory, an acid-base reaction is any reaction in which a hydrogen ion is transferred. An acid is an H+ donor, and a base is an H+ acceptor. A base must have an available lone pair of electrons that can form a bond to the H+ ion. You will often hear this described as acids donate protons and bases accept protons. Why is an H+ ion called a proton? A neutral hydrogen atom contains one proton and one electron. When a hydrogen loses its only electron, all that remains in its nucleus is a single proton. Therefore, for the most common isotope of hydrogen, an H+ ion is simply a proton. Some substances behave only as acids, others behave only as bases. Some are neither. There is also a special group of substances that can act as either an acid or a base. These substances are called amphoteric. Water, H2O, is an example of an amphoteric substance. When water reacts as an acid, water acts as a base. For example, HCl aqueous plus H2O aqueous produces H3O plus Cl-. In this reaction, hydrochloric acid donates its H+ ion, and water accepts it to form the hydronium ion. Water can also behave as an acid. Consider the reaction between ammonia and water. NH3 aqueous plus H2O liquid produces the ammonium plus ion aqueous plus the hydroxide ion aqueous. In this reaction, water donates an H+ to ammonia. Ammonia accepts the proton and becomes the NH4 ammonium ion. Water loses its proton and becomes the OH- hydroxide ion. The production of hydroxide ions makes the solution basic. Let's compare the Arrhenius and Bronsted-Lowry definitions. Every Arrhenius acid is also a Bronsted-Lowry acid. Every Arrhenius base is also a Bronsted-Lowry base. However, the Bronsted-Lowry definition includes some additional substances that can act as bases, such as NH3 and Cn-, even though they do not contain the hydroxide ions. Because of this, the Bronsted-Lowry theory provides a more complete description of acid-base chemistry.